Hi guys, this is Ms. Martinez, and in this video we are looking at the graphs of sine and cosine functions. The two objectives that you all have for this section are to be able to graph sine and cosine functions and classify them as periodic, and determine the amplitude and period of sinusoidal functions. Now, here's a little note for you. That term right there, sinusoidal, that is a collective term for the graphs of sine and cosine. So again, sinusoidal, that is the collective term when talking about sine and cosine functions together. So let's get started. The sine function, this is one that we have been working with a lot lately in our creating of the sine curve. We saw that what it is it is going to associate the measure of the angle from your unit circle that's in standard position with the y-coordinate, which is the height of your reference triangle. And that is your sine function. It is where the x values are the measure of the angle of your reference triangle. And then the height of your curve, like the one you see here, the height is determined by the height of the triangle in your unit circle. So this little 30-degree angle matches the height of the 30-degree reference angle. This 45-degree angle matches that in the unit circle, the height there. And the 60-degree matches the 60 in the unit circle. 90 is going to have a height of 1. It is just the length of the radius of your circle. The 120 is really the same as your 60-degree. The 135 is really a reference of 45, so they match. And that last little blue section there, 150, that is really the same height as your 30-degree. And it would continue in this process, but then below, because those heights are going down. They are, in fact, a negative measure. A bit of terminology here when talking about sine and cosine functions. Any function that has repeating patterns in the y values is called a periodic function. So these are periodic functions because they repeat. And that one repeating pattern is called a cycle. So it's periodic if it repeats, and the part that does the repeating, if you were to look at just one of those little sections, that is called a cycle. Right here between 0 and 2 pi is one cycle. After that, between 2 pi and 4 pi is another cycle. It goes up, descends, and then goes back up to 0. And if you look over here on the other side of the y-axis, there is another complete cycle where you start at 0, go up to 1, go down to 0, down to -1, and then back up to 0. The length of this wave, the horizontal length of your cycle, is called the period. And the period here would be 2 pi long. And it is 2 pi for each little cycle. Between 2 pi and 4 pi, that is a length of 2 pi. And the measure between -2 pi and 0 is 2 pi. So those periods are the length of the cycle. Last term here, the amplitude. The amplitude of a periodic function is just half the distance of its max and min. So you look at the high point, the low point. Here that would be 1 and -1. You take their difference and divide by 2. So the amplitude of this graph is 1. The cosine function it looks a lot like the sine function. It has the same kind of waving type pattern, but it just, instead of associating with the height, the cosine function associates the measure of the angle with the base of your reference triangle in your unit circle. And I've left some space there because we are going to actually put a picture of the cosine function in together. So let's talk about how you would determine amplitude and period for a function. These are the general definitions for sine and for cosine, where you could have different values of a and b. The only specification is b has to be a positive number. So a couple notes here. Remember, x represents the measure of the angle. The absolute value of a in this formula, in the general definition, is your amplitude. And if you come across a function like this, the period can be found by taking 2 pi and dividing it by b, the number just in front of x. So that's how you would determine your amplitude, by taking the absolute value of a, and the period by taking 2 pi, which is our typical period, and dividing it by the b value. Let's do this together. Let's say that we want to graph 3 cosine 1/2 x. Well, to graph we need to know the period and the amplitude. To find the period, you take 2 pi and divide it by your b value, which is 1/2. Now we can't divide by a fraction, so instead we'll multiply by the reciprocal, which will give us 4 pi. Our amplitude is just the absolute value of 3, which is 3. So the length of my wave is going to be 4 pi long. And if you've noticed, our wave can kind of be divided into 4 parts. And so we're going to divide our period into 4 parts. So that would mean that halfway would be 2 pi, and the subsequent parts would be pi and 3 pi. All right, now cosine starts at the high point, and it's supposed to look kind of like a cup shape. So it starts at the high point, which is, in this case, 3, because our amplitude is 3. The amplitude, you can kind of think of it like how loud your wave is. So it's a larger number, it's going to be higher. And then it goes to the 0. It'll go to your low point at 2 pi, back to 0, and again up to your maximum. And with a nice smooth curve, you could connect those in such a fashion that it looks like a cup. You want it to look kind of like a little canyon, where it starts to decrease slowly, slowly, faster, reaching a low point, and then going back up and cresting. So that would be a nice example of graphing a cosine function with a different period and amplitude than is the normal. So that is all that I have for you guys. If you had any questions, please write them in the margin and I would love to address them. Thanks. See you later.